All right, we are in the 8.5 note packet. Just a little refresher of what we learned. Okay, we learned some types of variations when we have this direct variation that in two variables are directly varies directly is usually how it's worded. Like if y varies directly as x, that means we have some constant that's being multiplied to the x variable. If it varies inversely, we have some constant divided by that other variable, such as like x. And then we also talked about joint variation, which just means multiple direct variations. So you can have a constant times x times another variable, and then combined, where there could be some types of direct and inverse relationships going on. Okay, so we actually tried to combine one, and then we looked at some equations and a table to identify direct inverse variations from that type of model. So as I just kind of told these guys, we pretty much like learned the concepts. Now we're just going to kind of do some example problems. And like I said, the word problems seem scarier than they are. You just basically have to kind of depict the type of variation, and it's usually stated. So like right here, before I even like read through all this, I see varies directly. So it's like those same steps every time. We're going to find a generic model. If they give us data, we'll be able to write a specific model by solving for our constant k. All right? Is this where we left off, right?
Yes.
Okay, class. The ideal gas law states that the volume V in liters varies directly. That's the keywords we're looking for in these types of problems. Varies directly with the number of molecules using N, which is in moles, and temperature T, which is measured in Kelvin, and varies inversely. Okay, so we do have a little combined relationship here with the pressure P in kilopascals. Pascals?
Pascals.
Pascals.
Yes.
Pascals. Write an equation for the ideal gas law. Okay, so we know the volume V varies directly with the number of molecules N and the temperature T. Okay, so varies directly means that they have some constant times those variables. So I'm going to write in N and capital T for temperature. Those are the variables they're telling me to use for that. So we have some constant times those if they vary directly. I'm not done. But everybody okay with that? Varies directly. Here's the tricky part. And varies inversely with the pressure P. So that means it has some constant divided by P.
I got it.
So I have a combined relationship here because I have some direct and some inverse relationships all in one. Did they give me any specific data? Any numbers?
I can tell you the value of the constant though.
Oh, actually?
0.08206.
Is that what it is?
Yes.
Wow. Hashtag impressed.
I'm so cool.
No.
All right.
No.
So it says write an equation. Because there is no numbers given to us here, we're just going to, because it's our generic model, that's all they want. We are not able to find a specific unless we know the constant off the top of our head, or we're given numbers and data to solve for K. All right, let's try one more like that. The volume V of a geometric figure varies jointly. That means I have multiple direct variations going on with the square of the radius of the base and the height. Write an equation for the volume. All right, so the volume, I'm just going to use a capital V. Varies jointly, that means I have some constant times other variables. Okay, jointly means a bunch of direct variations. Nick, you want to go ahead and finish this up?
R times R squared times H.
Good. So with the square of the radius, so we said times R squared, I would have used R for radius 2 of the base, and times H times the height. In this first piece of information, are we given any numbers?
No.
No. Okay, so that's all they wanted. Now this follow-up question says, well, estimate take the constant of variation, that's the K. When your volume is 63 and 1/3, well, I guess I don't know if this is 0.3 repeating, I should assume. 63.33, when your radius is 2.4 inches, and when the height is 10.5 inches. So here's where you get to plug all that information in. So I know the volume is 63.33, so I'm honestly going to plug that in for my V. K is what I'm trying to find, the constant of variation. When the radius is 2.4, don't forget we need to square that according to our equation. And the height is 10.5. Okay, makes sense? This is usually what the second step is in these types of problems, is they'll give you a relationship between the variables, and then you solve for the constant. All right, I multiplied these numbers together, and I got 60.48. I'm going to put that in front of my constant just because that's how you're used to seeing it in equations. You don't have to, because you know to solve for K, we would just divide by that 60.48 number. And I got K to be a pretty long decimal. So we'll just round it to 2 decimal places for now. You can do 2 decimal places, unless it says like otherwise. If it says, I know there's some, what was that, the geometry homework I was doing, where it said round to the nearest whole number. I can't remember if I was doing your guys' homework on geometry, or maybe it was, I don't know. Anyways, I'm okay with 2 decimal places. So that's all we technically needed to do. So this is our generic model, or generic equation, whatever you want to call it. Let's just go ahead and take this one step further. Let's write our specific equation, which all that is just plugging in that constant. I'm just going to do 1.05 r squared. No other numbers we're going to plug in. That right there would be my specific model. See, these aren't bad, these word problems.
They're not that bad.
It's just picking out the relationships. Okay. Let's try one where we're given quite a bit of information. The force F needed to loosen a bolt with a wrench varies inversely with the length L of the handle. Write an equation relating F and L, given that, okay, let's just start with setting up our generic equation. Okay, and then we'll kind of plug in and solve for the constant. That's always the first step. First step, write your generic model. So my force F, let's see if somebody else can write it for me. If it varies inversely with the length L, how would I write that as an equation? Connor?
I think it was K over L.
Good. Varies inversely, so it's some constant divided by the other variable. I use a lowercase l like that. There's our generic model. Okay. How did I know that? They told me it varies inversely, so I know it has this type of relationship. Does that make sense? All right, now, they're giving us data in the second part of this sentence that I started to underline. They're giving us data so that we can figure out a specific equation. All right, so our second step here would be to solve for K. All right, so I know that when I have 250 pounds of force, now I'm going for F, and I kind of work my way across the page, like do the step-by-step. You can organize your work differently, obviously. I know that I need 250 pounds of force to loosen a bolt when the handle is 6 inches long. So that's your L. Here's the data they're giving you so that you can write a specific equation. So to solve for the constant, you just need to times this by 6. So that K value here is 1,500. So now we can write our specific equation. F equals 1,500, not over 6 though, over L. Over L. For your specific equation, the only number you should have in there is the K value. All right, now that we found that, they're going to ask you a follow-up follow-up question. So they're asking you how much force must be used when the wrench is 24 inches long. So I'm going to use this equation. So this is my third, this is my follow-up. I'm trying to figure out how much force is needed to use. Here's my equation. It's always 1,500 divided by the length of the wrench, which is 24. So that would give me 62.5. Pounds of force. That's technically the final answer to that question. You follow these steps every time. These word problems are not that bad. Set up the generic model with the relationship, whether it's varies directly, inversely, jointly combined. Use the data to write a specific model. Use that to answer the question. Okay, questions?
No.
Okay, we're just going to do one more because it's pretty much the same every time.
Okay. I got the answer.
So,
For our last one.
do we need that
Bro,
link?
what do you think it is? What do you think it is?
I don't know. What'd you get?
Well, you tell me yours first. No, I guess you first.
Which part of it?
The last part.
64 over 9.
That's not what I got.
Ooh.
What'd you get for K?
3:30 seconds.
Ooh.
That's
I
what I got.
What'd you get? I got 1.83.
For the constant?
Yeah.
I kept it as a radical.
Do I have to?
Yeah. Yeah. All right. All right, team. Let's show these guys how to do it.
I know. I did it right. I just didn't keep it right. Yeah.
All right. X varies jointly. What does jointly mean?
Multiply.
Multiple. Yep. Multiple direct.
Yeah.
Multiple direct. So if X varies jointly, it means we're going to have multiple direct variations, which is times in. Okay, it varies jointly with W and the square root of Z. All right, there's my generic model. Follow-up question says, find the specific model if X is 3/2, when W is 2 and Z is 6. All right, so in order to find the specific model, I have to figure out what K is first, right? So here's my data. X is 3/2. The only thing that's kind of tricky about this one is we have radicals. Constant's what I'm trying to find. When W is 2 and Z is 6.
Oh, I know what I did wrong.
Okay, if you get a new answer, let me know. All right, so I'm going to solve this for K. The first thing I did is I got rid of that 2. I was like, let me just divide off that 2. There's multiple ways you could solve this, and you get 3/4. You're dividing by 2, you're really just times by another half, or if you're already dividing by 2 and dividing by 2 again, you're just dividing by 4. That's the math there. And then I divided by the square root of 6. You can do that in one step if you're okay with that algebra, but if you need to do it step by step, totally fine. Okay, here's where it gets a little dicey. So basically, like what I just said, similar with the 2, if you're already dividing by 4 and you're dividing by another root 3, that's that math there. Okay, or if that confuses you, think of it as timesing by the reciprocal. You're yeah, where did I get the 3? I have no idea where I got the 3. Sorry. Good catch. 6. Okay, so does that math make sense? You're really dividing by the square root of 6, which as a fraction, that's square root of 6 over 1. So you can also think if that confuses you, how to get there, times by reciprocal, you get the same thing. All right, now, so this is what I told Connor, is we want our constant kept as a radical, not as a decimal. What's wrong with this?
It's in the denominator.
There's a radical in the denominator, so you have to rationalize this. I'll come over here. How would I rationalize this, friends?
Times the root 6.
Times the top and bottom by the square root of 6, because I will get a perfect square in the denominator. So up here I have 3 root 6. Down here I have 4 times root 6. Root 6 is the square root of 36, which is just 6. Okay, can I reduce that? You betcha. 3 over 24 is 1/8. There's my constant. Woofda. Okay, so let's write our specific model now. So our specific model would be x equals square root of 6 over 8 times w times the square root of z. And a very common mistake in these problems is people want to like plug these numbers in to the specific model. So this is actually the answer to this question. Find the specific model. The only thing you plug in is the k value. Don't be that person that plugs in a bunch of numbers. If it looks like this, if your answer, don't write this down. If your answer looks like this, that should be like, I'm doing something wrong. When have I ever seen a model that looks like with just numbers, right? Okay. All right, so then they're going to ask you a follow-up question. Now that you have your specific model, they want you to find z when x is 1 and when w is 4. Okay. So here's my specific model. When x is 1, so I'm going to plug 1 in for x. When w is 4, they want us to find z. Okay, a couple ways you could do this. I times these together first, or based on what we kind of just been talking about with fractions, you could cancel these, make this a 2. Next, I would probably times both sides by 2 to get rid of this. A couple different ways you could do this algebraically. Guys, what's the square root of 6 times the square root of z? Square root of 6z. Right? We can multiply them together when they have the same index. The radical doesn't go away. The only reason the radical goes away when we do something like this, you guys, is because what you're really doing is you're getting the square root of 36. What's the square root of 36? 6. Okay, this one's just not a perfect square. How would I solve this?
Both sides.
Square root both sides?
No, square.
Square both sides. Good. Square both sides. You get 4 equals 6z. Z is 2/3.
I did mine differently.
I know. I said there was a lot of different ways you could solve it algebraically.
Okay.
So it's fine. I mean, a lot of different ways you could get z by itself. You could have divided both sides by the square root of 6. I didn't want to do that because then I'd have to rationalize. But when you squared both sides, I guess it would go away too. So, but you still got 2/3?
Yep.
Okay.
Yep.
All right, got it?
Yep.
Follow those steps every time. I'm going to stop the recording quick.
Hi, Willis. Bye, Riley to the aggravated.
How about you?